Hey everybody, so today we're going to do some notes on arithmetic and geometric sequences. There will be a lot of information that you guys already know. This is to help you with the March 30th to April 3rd worksheet. I'm going to do some problems straight off of that worksheet to help you see where the answers are coming from and to help you get going. So number one, we have a sequence 17, 10, 3, -4, -11. Okay, and the goal for problems 1 through 8 is just to state if the sequence is arithmetic or geometric. Arithmetic sequences are created by repeated addition or subtraction of the same common difference. In this case, these numbers are all going down 7, so -7, -7, -7. Because they're all going down 7, this is an arithmetic sequence. So arithmetic is addition and subtraction. Of the same common difference. And the common difference, we use the letter D, and that would be -7 in this case because they are going down 7, down 7, down 7. Okay, number 2, 3, 9, 27, 81, 243. Okay, so notice these are increasing by more than the same amount. So I can tell that these are multiplying by 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, and so on. This sequence is geometric, and geometric sequences are repeated multiplication and division of the same ratio, and we call that ratio R, and in this case R is 3. Another word for ratio would be multiplier. Okay, so let's move down to number 9. So in problems 1 through 8, all you need to do is identify them as arithmetic or geometric. You don't need to find this information, but I'm hoping it will help as we go on. So number 9, 36, 27, 18, 9, okay. And the first thing I'm going to do is find the common difference. So I can tell that these are going down by 9, -9, -9, -9. If you ever get into a situation where it's difficult to tell, what you can do is take the second number minus the first number. D, common difference, equals 27 minus 36, which is -9. So if it's ever hard for you to just figure out the pattern here, then you can take the second number minus the first number to get your common difference. Okay. The next thing we're going to do is find the explicit formula. Because this is arithmetic, so I can tell it's arithmetic because it is going down 9, down 9, down 9. and it is subtraction each time. The equation, the explicit equation, looks like this. Okay, this might look very, very strange to you. However, what I want you to do is think about this. Okay, so this concept hopefully should be very familiar to you. This is y equals slope x plus y-intercept, or starting point. Okay, for sequences, it's very similar. This would be y equals, and then d is the growth, or the common difference. N is a letter, so times n, plus the 0th term. Okay, so let me explain the 0th term for a moment. So right now you have your list of numbers in your sequence, and those numbers are in order. Number 36 is the first number in the sequence. 27 is the second number in the sequence. 18 is the third number, and 9 is the fourth number. Okay, what we need to do is go backwards 1 to find the 0th number, and that will be what we plug in here. Okay, one of the ways that you can get that is to do the opposite. So if I go down 9 each time and I want to go backwards, I'm going to go up 9. What is 36 plus 9? 36 plus 9 is 45. So t of 0 equals 36 plus 9. I'm doing the opposite. 45. Okay, we're ready to write our equation. T of n equals growth, which is the common difference, negative 9n, plus the 0th term, which would be 45. Remember, there would be a 45 in front of this sequence. Okay. In the answers for this worksheet, you will notice that the equation is written a little bit differently. This is how we write it in our book. There are two different ways to write this, and so let me give you the second way so that you can match up your answers with the answers on the worksheet. So this will be t of n will look like this, a sub n equals, and then what they like to do is put the constant, the 0th term first, and then just kind of switch this around. So that comes first and that comes second. These are equivalent. Those are the same thing, but this is kind of how our book writes it and introduces it. And this is how the worksheet shows the answer, so I wanted to make sure that you could see your answer was correct on the worksheet answers. Okay, now the last thing we have to do for number 9 is find the 52nd term, which means that we are going to find a sub 52. What that means is if I started here and I subtracted 9 all the way out to the 52nd number, I don't want to have to do that. I could, but I don't want to have to do that. Because I have the equation, I don't have to. What I can do is plug in 52 for n. So 45 minus 9 times 52. Okay, take my calculator. 45 minus 9 times 52 is negative 423. So a sub 52 is negative 423. And I know that that seemed like that problem took a while, but they'll get much faster as you go Okay, now to number 17. This is the last one I'm going to do. -3, -6, -12, -24, ... Okay. The first thing we need to do with this problem is recognize that it's not increasing by the same amount each time. This one is going down 3, then down 6, then down 12, which means that it is not arithmetic. However, I notice that if I go times 2, times 2, times 2, I get my sequence, which means that it is geometric. Times 2, times 2, times 2. Okay, now I can tell that the ratio r, the multiplier r, is 2, but let's pretend that I had a really hard one that I couldn't figure out. One of the ways that you could find r, if you can't figure it out just by looking at it, is take the second number divided by the first number, and that's 2. Okay, now let's work on the explicit equation. The explicit equation for a geometric sequence is a little bit different. If you guys think back to the last thing we did before we left school, we had those the multiplying rabbits problems, and we had kind of this repeated multiplication. So we had -3 and then times 2, times 2, times 2. And those look like y equals ab to the x. Okay, so how am I going to work this into my equation in sequence format? T of n equals, okay, so I want the 0th term to come first, times r to the n. Okay, so the 0th term is going to go here, times r, which is our ratio, which is 2, and then n will just stay a letter. Okay, this is a little bit tricky, so I'm going to number my terms here. So this is the first number in the sequence, second number, third number, fourth number. What I need to plug in is the 0th number. What number would come right before this? Okay, well, if I am multiplying by 2, I can go backwards by dividing by 2, which would give me -1.5. Okay, let's write that down here. T of 0, 0th term would be the first term, and instead of multiplying by 2, I would divide by 2, which would give me -1.5. So -1.5 would be in front. Okay, so T of n equals -1.5 times r is 2, that's the multiplier, to the n. Okay, now the worksheet is not going to write this, they are going to write a sub n equals -1.5 times 2 to the n. These are equivalent, they just have a little bit of a different notation, but I want you to be able to match up your answers again with the worksheet answers. Okay, last thing, it asked us to find the 8th term. So I am going to plug in 8 for n. I could actually find the 8th term pretty easily by just using my calculator, but that's okay. Alright, so I've plugged in 8 here and 8 here. -1.5 times 2, and then the exponent button is here. It's this upward arrow, it's called a caret, times 2 to the 8, -384. Okay, that's it for this worksheet, guys. There are some regular old equations at the bottom, 25 to 32. And I hope this helped. Talk to you guys soon. Thanks.